When a curve is expressed using parametric equations, you can find the Cartesian equation by eliminating the parameter. So here our parameter t. So find the Cartesian equation of the curve with parametric equations x equals 2t minus 1 and y equals 8t squared plus 3. So what we'll do is we'll make t the subject of the first equation, and then we'll substitute this into our second one, y equals 8t squared plus 3. So this will give us x equals 2t minus 1. So therefore we can say that x plus 1 over 2 will equal t. Putting this into the second equation will give us 8x plus 1 all squared over 2 squared plus 3, which will give us 8x squared plus 2x plus 1 over 4 plus 3. And this is just now simplifying down, which will give us 2x squared plus 4x plus 5. The second one, this second example, is slightly more complicated in that we've got sine theta and cos theta in each of our parametric equations. But we do know an identity linking sine theta and cos theta. We know that sine squared theta plus cos squared theta equals 1. So we need to use this and try and link our parametric equations with this identity in mind. So we can say that x minus 3 over 2 equals sine theta and y plus 5 over 2 is cos theta. Then using sine squared theta plus cos squared theta equals 1, I can say that x minus 3 all squared over 4 plus y plus 5 all squared over 4 must equal 1. So x minus 3 all squared plus y plus 5 all squared will equal 4. If you haven't done so already, I'd like you to work through exercise 3b as a minimum, questions 1, 2, A, B, D, but I think you should perhaps have a go at some of the harder questions. We can also differentiate parametric equations using the chain rule. So if we know what x is equal to, we can work out dx by dt, and similarly work out dy by dt and use the chain rule to work out dy by dx. So in our first example, if x equals t cubed plus t and y equals t squared minus 1, then dx by dt will equal 3t squared plus 1, and dy by dt will equal 2t minus 1. Therefore, dy by dx will equal 2t minus 1 over 3t squared plus 1. Looking at the second example, the first one, dx by dt, is straightforward to differentiate because we know that the derivative of cos x is minus sine x. But looking at the second one, we've got 3 sine squared t, so we can see that we're going to have to use the chain rule on this first before we use the chain rule to work out dy by dx. So if x equals 2 cos t, we can say, and y equals 3 sine squared t, we can say dx by dt will equal minus 2 sine t. However, with the second one, I'm going to say let u equal sine t, so du by dt will equal cos t, and y will equal 3u squared, so dy by du will be 6u, which will give us dy by du t as 6 sine t. Therefore, dy by dt is 6 sine t cos t. So using the chain rule, we can say dy by dx is 6 sine t cos t divided by minus 2 sine t, which will give us dy by dx equal to minus 3 cos t. Now in this example, we've been asked to find the equation of the normal at the point minus 8, 4 to the curve which is given parametrically by x equal t cubed and y equals t squared. So we need to work out, so for any equation for straight line, we've got the point that it goes through, minus 8, 4. So we need to work out what dy by dx is. So we're going to say at the point minus 8, 4, x equals t cubed and y equals t squared. So we can say that minus 8 equals t cubed, so t must therefore equal minus 2. And subbing in y equals 4 will give us 4 equals t squared, so t will equal plus or minus 2. Then both our parametric equations are satisfied by t equals minus 2. So this is the value that we're going to use. Now differentiating with respect to t, we'll get dx by dt equals 3t squared and dy by dt will equal 2t. Therefore, dy by dx will equal 2t over 3t squared, which simplifies down to 2 over 3t. So at the point when t equals minus 2, dy by dx will equal 2 divided by minus 6, which is minus 1/3. Therefore, the gradient of the normal will be equal to 3. So now I can work out the equation of the line going through the point minus 8, 4. So the equation of the normal will be y minus 4 equals 3x plus 8. Minus minus is a plus. So y equals 3x plus 28. Now in this example, we've been asked to find the equation of the normal at the point 8, 2 to the curve which is given parametrically by x equals 4t and y equals 4 over t. And we've been asked to find the coordinates where this normal crosses the curve again. So the normal meets the curve at the point 8, 2. We want to work out the other coordinate. So we can see here that we're going to need to solve these equations simultaneously. So we'll find the equation of the normal, and we also need to write our parametric equations as a Cartesian equation with y as the subject, then equate these two to work out our x coordinate. So we can say if x equals 4t, then dx by dt will equal 4. And if y equals 4t to the minus 1, then dy by dt will equal minus 4t to the minus 2, or minus 4 over t squared. So dy by dx is going to equal minus 4 over t squared divided by 4, which is minus 1 over t squared. So when x equals 8, we can say t equals 8 over 4, which equals 2. So when t equals 2, dy by dx will equal minus 1/4. So the gradient of the normal at the point 8, 2 is going to be equal to 4. So if the gradient of our normal is 4, then the equation of our normal at the point 8, 2 is going to be, so the equation of the normal will be y minus 2 equals 4x minus 8. So y will equal 4x minus 30. Now writing the parametric equation as a Cartesian equation will make t the subject of one and sub it into the second one. So if x equals 4t, then we can say that t will equal x divided by 4, and I'm going to sub this into y equals 4 over t, so this will give me 4 divided by x over 4, which is 16 over x. So our Cartesian equation is y equals 16 over x. Now we're going to solve these equations simultaneously, and this will give us the points, the coordinates of the points of intersection, so where the normal intersects the curve. So if y equals 16 over x and y also equals 4x minus 30, we can say that 16 over x equals 4x minus 30, and we're going to rearrange this to give us 16 equals 4x squared minus 30x. So 0 will equal 4x squared minus 30x minus 16. And I'm then going to divide through by 2, and this will give us 2x squared minus 15x minus 8, which I can factorise down to give us 0 equals 2x plus 1 and x minus 8. So this means that x will equal 8, which we have already been given in the coordinate 8, 2, or x equals minus a half. So if x equals minus a half, that means that 16, y equals 16 divided by minus a half, which is minus 32. So the other coordinates of intersection is going to be minus a half minus 32, and the given one 8, 2. If you feel happy with these, you can go through these examples again, but I would now like you to work through exercise 3C. I'd like you to work through all the questions, showing all you're working out methodically and clearly, and just be careful you don't make any slips, and check your differentiation, and then move on to some of the more difficult questions to round this off in the miscellaneous exercise 3.